Okay, so on the next one, what we're going to be using is adding the effect of as it gets unstable, it also starts to kind of grow slightly based on. We can use the scale as well as the my scale as an attribute. You could generate another attribute just for that, but I'm going to keep it linked to just one attribute, my scale. So what we want is to offset each one of the faces according to its normal away from the center as it starts to get unstable. We do have this one that's animated, so I'm going to color it differently, pressing C and give it a different color so I know that this one is animated by hand. And okay, let's figure out the directions. Pretty straightforward. So let's create another point triangle. And let's say that each one of these points, remember, even though we're looking at faces, each one of the face is back fragment represented by or associated to a single point. So that's why we keep using point triangles. So on the point triangle here, let's set that the normal of each one of those points is going to be equal to a normalized position. And that's the beauty of spherical structures. Normalized, V. Not normalized, normalize. You crazy David. Okay, so the beauty, as I was saying, is because we are working at origin, the normal that we're interested in is a radial normal. And because we are working at the origin, each point position, actually the vector of each one of these points position pointing is going to be pointing from the origin to the point. That's the point vector. So if we normalize it, we'll get the normal vector that we are actually interested in. Okay, so pretty easy. Set normal. It would only be slightly more complicated if we weren't at the origin, or if the structure wasn't spherical. Then we would have to find another way. Still wouldn't be that complicated anyway, but this is definitely the easiest one possible. So we now, each point will have its own normal. Let's turn this on again. No, not going to work this time. But maybe we can have a look at the points and we can have a look at the normals. Not really, but they are there. Let's middle mouse button and check. We do have the normals, so everything's good. Let's just trust that they're there. We can always check the spreadsheet as well. So we do have a vector normals. Nice. Now, the next step is going to be for us to actually animate that based on my scale. So we can use exactly the same system. So let's, in this case, I'm going to be using a point triangle instead of a transform. So let's go with the point triangle. This is also going to be animated. I'm going to want to control when this effect kicks in, not from the start. And so point normal, anim, normal offset. So what are we going to be saying? We're going to be saying that the new position is going to be plus equals. It's going to be equal to, let's write it in a more straightforward way. So it's going to be equal to the current position plus the vector normal multiplied by, you may have guessed, the attribute that we're going to be using for this. So it's going to be, again, my scale. And because we will want to make sure we do have some control over this, so let's create already a parameter that we can animate for this. So let's say multiplier, offset multiplier, offset mods. Okay, let's start at 1 so we can actually see what's happening. Okay, it's a bit too strong. Could be interesting. Let's have a look. So we do have all the layers here. If we play with the multiplier, you'll see it's kind of just exploding. Okay. So that's not very interesting, though. I was thinking of having something more of a gradient where we would have the outer layer expand a bit more, and so the closest to the center, the closest to the center they are, the less they expand. So that's something we can actually create as well. Okay. So right now they just expand all of them together. It does give us an interesting effect though. Okay, and it is different because of they were all kind of having the same effect, because in the beginning we do have the uniform value for my scale, so nothing much was actually happening. But as it gets unstable, as we animate the scaling effect, we were also getting some. Now we, at this point of the animation, we do get some of that interesting transition going on. I think this is cool. I think this works well. So we would kind of synchronize both, I guess. Let's say the I'm gonna kind of just copy this. Maybe not all the way. Copy parameter. And here, let's put the same thing. Base relative reference. But let's not go to that far. So I'm just applying a multiply of 0.5 so it doesn't go all the way. Though it might be interesting. Let's see. No, it's actually interesting, this size. I like this size. Let's have a look at the wireframe. So it's stable and then it starts to become kind of more unstable. Pretty cool. It activates and then it deactivates. Okay, interesting effect overall. So when the faces have their actual scale, when my scale is closest to 1, they will be more offset. That's something that you may want or not, but I think it's an interesting rhythm to have. As I said, you can create another attribute noise with a different offset value, and that will give you for a different attribute, and you can use that second attribute to actually control this offset. But I'm kind of synchronizing both, and I think it's an interesting feature to have. The biggest they are, the furthest from the center they are, and then as they get closer to the center, they get smaller. And yeah, I think that gives us some nice readability for whatever's happening in the core of the artifact, and that's something that we're going to be working on as well. Cool. Okay, so now we have this effect as well, and let's move on to something else.